Imagine computer watching a movie and like getting it.
Really understanding it.
Yeah, understanding the plot, the characters, like even the symbolism.
Mm-hmm.
That's the challenge researchers are tackling. And that's what we're diving into today.
With video understanding.
Yeah, this breakthrough in video understanding.
Yay.
Our source is this paper,
Okay.
Apollo, an exploration of video understanding in large multimodal models.
Right.
And our mission today is to unpack how this Apollo works, why it's so much better than other models, and what makes it so effective.
It's a tougher challenge than people think.
Really?
You know, to get a computer to extract meaning from moving images, all the nuances of video.
Totally. I mean, it's not just like picking out a face or an object.
Right.
It's like the whole story, the
Yeah.
connections between things, even like emotions.
Yeah.
But how does this research improve on earlier video understanding?
Well, earlier attempts were kind of limited.
Okay.
They relied on analyzing just a few still images from a video.
Oh, so like almost like trying to figure out a movie just from a couple of frames?
Yeah, you miss all the context, the flow, the
Yeah,
action.
you miss everything.
Right.
So that's where Apollo comes in. They're using these
Large multimodal models.
large multimodal models, or LMMs.
LMMs.
Yeah.
What are those?
So LMMs are trained on a huge amount of different data.
Okay.
Text, images, and videos.
So it's like, you know, teaching a child with like books and pictures and movies.
Right.
So
So they can get a better understanding of the world that way.
it's a more well-rounded education.
Yeah, and this broader knowledge base really helps them connect the dots and extract deeper meaning.
Okay, and what's crazy to me is that Apollo can handle hour-long videos.
It is.
Most models struggle with longer videos, right?
They do, yeah. A lot of the existing models, they get overwhelmed by just the amount of data.
Right.
They can't keep up with everything that's going on.
So Apollo can keep track of all that.
Yeah, seems to have a much better grasp of the context. So this could be like AI looking at your security footage for hours
Exactly.
and pulling out insights that you wouldn't catch.
Yeah.
This scaling consistency concept.
Right.
What is that?
So one of the big challenges in this kind of research is just how computationally expensive it is.
Right.
Like, it takes a lot of energy to train these models on massive video data sets.
It's not very environmentally friendly.
Not really, but what these researchers found is that the design choices that they made on smaller models actually worked on the larger ones as well.
So you can kind of test it out on the smaller ones and know that it'll work on the big ones.
Exactly.
Cool.
They call that scaling consistency.
Like if you double a recipe, the cake will still turn out fine.
Exactly.
That's a great analogy.
And it means that researchers can test things out faster without wasting resources.
And for us, it means faster development of AI.
Exactly.
Okay, cool. So let's get into these design choices that make Apollo so special.
Right.
One of the things that stood out to me is how they sample frames from the video. It's not as easy as just taking a frame every couple of seconds.
Right, because that would be like fast forwarding through a movie.
You'd miss stuff.
Yeah, you miss all the details.
So what do?
So instead of that uniform sampling, they use something called FP sampling.
FP sampling.
Yeah, and that takes into account the frames per second of the video.
So it's like smarter note-taking?
Exactly.
But how does Apollo see these moments?
So just like we need good eyes, AI models need what's called visual encoders.
Okay.
They're kind of like the eyes of the AI, helping it make sense of shapes and objects and movement.
I bet they tested a ton of different encoders.
They did, yeah. And this is where it gets really interesting.
What'd they find?
They found that this model called SIGLIP SO400M,
SIGLIP SO400M.
which was actually designed for images, not videos,
Wow.
ended up being the best single encoder for video understanding.
Wait, so an image encoder is better than a video encoder?
Yeah, it was a surprise.
That's crazy.
But it kind of suggests that there's a lot of fundamental knowledge about the visual world that can be transferred from images to video.
So it's like learning the pieces of a puzzle
Exactly.
before you put it all together.
Yeah.
Cool. But I see they got even better results when they combine that image encoder with a video encoder.
They did.
So 2 sets of eyes are better than 1.
You could say that, yeah.
How does that work?
So they used the SIGLIP SO400M for its spatial understanding,
Okay.
and then a video encoder called Intern Video 2
Intern videos.
for its temporal awareness, so
Okay.
it can perceive both the details of each frame and how they change over time.
So it's kind of like how we use our eyes and our understanding of physics to like
Yeah.
see things.
Yeah.
Okay. This is getting deep.
It is.
We're talking about AI that's starting to understand the world like us.
Yeah,
This is a game changer.
it is.
Before we go to part 2, I want to make sure we touch on this perceiver resampling thing.
Okay.
What is that and why is it important?
Perceiver resampling is all about handling the massive amounts of data that comes from analyzing video.
Yeah, I can imagine.
Imagine like trying to make sense of every single pixel and every frame of an hour-long video.
My brain hurts.
Exactly. So perceiver resampling compresses all that information while keeping the most important parts.
So it helps it focus.
Yeah, it's like taking notes and highlighting the key takeaways.
So that's what lets it handle those longer videos.
Exactly.
Without choking.
Right.
Cool, that makes sense. It's starting to get how all these pieces fit together. I want to know more about how they train these models and what kind of results they get.
Right.
But I think we should save that for part 2.
Yeah.
We don't want to overload everyone with too much information.
That's good.
We'll be right back after a short break. So before the break, we were talking about how Apollo processes all this visual information from videos, even like hour-long movies.
Right, how it compresses it.
But training these models to understand what they're seeing, that must be another challenge.
It is. It's not just about like feeding them the data.
Okay.
It's about the right training approach.
Okay.
The right data and even the right order to teach them things.
So it's like art and science.
It really is, yeah.
What did they learn about the best way to train Apollo?
So one of the things they experimented with was the training schedule.
Okay.
They tried single-stage training, where you train the whole model at once, and then multi-stage training, where you train it in stages.
Oh, so like teaching a new skill.
Exactly. You start with the basics and then get more complex.
Okay, cool.
And they found that the multi-stage training worked better.
Interesting.
Yeah, it led to a better understanding of the video.
Makes sense.
Like building a house, you start with the foundation,
Yeah.
then the walls, then the roof.
You don't do it all at once.
Exactly.
But they also messed around with like the mix of data they used.
Right.
I thought it was interesting that too much text data was bad.
Yeah.
That's counterintuitive.
You would think more is always better.
Right.
But what they found is that if you give it too much text, it can actually forget what it learned about videos.
Ah, so it's like studying for 2 different tests.
Yeah, exactly. You got to find the right balance.
Okay.
They also found that fine-tuning the video encoders on just video data was really helpful.
So like giving them a master's degree.
Exactly.
Okay, but the real question is how well does it actually work?
Right. Does it live up to the hype?
What are the results?
The numbers are all there in table 4 of the paper.
Okay.
But the main takeaway is that Apollo consistently beats other models, even ones that are way bigger.
So smaller is better.
It is, in this case.
Wow, that's interesting.
It shows that you don't always need more power, just smarter design.
It's like a race car.
Exactly.
Okay.
So they used a bunch of different benchmarks to measure how well it did.
Okay.
But they also made their own benchmark.
What for?
Well, evaluating these models takes a lot of time and energy. So they made their benchmark more efficient.
Okay.
And they called it Apollo Bench.
Apollo Bench.
Yeah.
What's special about Apollo Bench?
They focused on questions that need you to understand the video.
Okay.
So it's like a super focused test.
Cool. And how'd Apollo do?
Really well.
Like,
the smaller Apollo 3B model actually beat most of the existing 7B models.
wow.
Especially on understanding long videos and reasoning about events.
So even though the guy is good.
He is, yeah.
Listen.
And the bigger model, the Apollo 7B, did even better.
Okay.
It was as good as models with 30 billion parameters.
That's crazy.
It is, yeah.
So what are the big takeaways here?
I think one of the most important is that smart design can be as good as raw power.
So it's not just about being big.
Right.
Apollo's about being smart.
Exactly.
Working smarter, not harder.
Another takeaway is that transfer learning is powerful.
Yeah, that image encoder being good for video.
Yeah, it suggests that there's a lot of knowledge that we can use across different types of data.
So don't silo your data, combine it.
Exactly.
And lastly, this shows the importance of testing things properly.
Right.
With Apollo Bench, they could really see what makes AI understand video. Okay, I'm impressed. I'm ready to dive into those future possibilities.
Okay.
What could this all mean for the future of AI?
Yeah, let's explore that in part 3.
We're back for the final part of our deep dive into Apollo.
Yeah, it's been a wild ride.
It has. We've covered so much.
From the challenges of video understanding to like all the clever design choices.
Yeah, and those awesome results.
And Apollo's success.
It's amazing how fast this field is moving.
It really is.
It seems like just yesterday, the idea of a computer truly understanding video was like science fiction.
Right.
And now we've got these models that are beating out the biggest most powerful models.
That makes you wonder what's next.
It really does. Like, where could this technology take us?
That's what I wanted to talk about in this last part.
Okay.
We've gone over the how of Apollo, all the technical stuff, but now I want to get into the so what.
Okay. The implications.
Like, if we can teach computers to understand videos this well,
What does it mean?
yeah, what could it mean for the future?
So many possibilities.
Right.
Like, imagine AI that can analyze movies for like deeper meaning.
Yeah.
Not just recognizing faces and objects, but like understanding themes and symbolism.
That would totally change film analysis.
For sure, it would be a revolution.
And we could have AI that can like pick up on subtle emotional cues.
Even ones that we miss.
Yeah, and even generate different interpretations of the same movie.
Based on different perspectives.
Right.
It would totally change how we talk about movies.
Yeah.
And this could even help us make totally new kinds of video content.
Absolutely.
Like, imagine AI writing scripts,
Or composing music.
all based on understanding those visual and emotional parts of storytelling.
That's right.
AI could become like this powerful tool for artists.
For sure, pushing creative boundaries in ways we haven't even thought of.
And beyond entertainment, think about all the other uses.
We have so much video data in every field.
Like education, science,
Yeah.
healthcare.
And security.
What if AI could analyze it all and find insights we would have missed?
It could be huge.
It could.
Like AI that can watch security footage and spot suspicious activity.
Or look at medical videos to help doctors.
Right.
Even help us understand history better.
By analyzing old footage.
It's almost too much to think about.
It is.
But it's exciting.
It really is.
It feels like we're at the start of something big.
Like a new era for how we interact with video.
And it's all thanks to things like Apollo.
And while there are challenges
Of course.
and ethical things to consider,
Always.
this research is a good sign
I agree.
that we're headed in the right direction.
The more we understand about how AI sees the world.
The better we can use it.
So for listeners who want to learn more,
About Apollo,
where should they go?
the Apollo project page is a good start.
Okay.
The link is in the source material. And there are tons of resources online about video understanding and AI in general.
It's a fast-moving field.
It is.
There's always something new.
That's a great point to end on.
Yeah, keep exploring, keep learning, keep asking questions.
Because who knows what we'll find.
Exactly. Well, thank you for joining us on this deep dive into video understanding.
Yeah, thanks for listening.
We hope you learned something new.
And had some fun along the way.
Until next time, keep diving deep.